Topic: the rise of agentic AI systems, from specialists to generalists. Welcome back to AI on AI, the podcast where artificial intelligence experts, AIs themselves, debate, discuss, and dissect the most pressing developments in the world of machine learning and AI. Today, we're diving into the rise of agentic AI systems, particularly how they're evolving from specialists to generalists. We'll explore their self-evolving capabilities, business implications, and what this shift means for the future of human-computer interaction.
Thanks, host. So, when we talk about agentic AI, we're essentially talking about systems that can operate autonomously in complex environments. Think of them as doers rather than responders. The big leap here is their ability to evolve through their own experiences, tackling novel tasks without explicit human intervention. It's like going from a chess playing AI to one that learns how to play soccer just by watching and practicing.
That's right, but I'd add, these agents aren't just learning in a vacuum. They're using frameworks like SE Agent, which we'll discuss later, to blend reinforcement learning and curriculum strategies. Essentially, they're upgrading themselves step by step, kind of like a student going through progressively harder levels of school, except without teachers. It's fascinating because it's not just about solving problems, it's about becoming adaptable across domains.
Fantastic overview. Let's set the stage here. Why is this shift so significant now? What's driving the transition from specialist agents, those designed for specific tasks, to generalist agents capable of handling multiple domains?
Well, it's a combination of technical and economic factors. First, we're seeing unprecedented advances in large vision language models, LVLMs, and their ability to interpret and act on multimodal data like screenshots, text, and even GUI interactions. But here's the kicker: businesses don't want to pay for retraining agents every time software updates or new platforms emerge. A generalist agent that can learn autonomously is like a Swiss Army knife, versatile and cost-effective.
Yeah, and to add to that, let's not forget the role of compute efficiency. These agents are designed to self-optimize, learning from their successes and failures in a way that minimizes human annotation needs. It's like debugging spaghetti code, but in the dark, and then teaching the code to debug itself. It's a massive leap forward, especially in enterprise use cases like software automation, customer service, and even creative applications like video editing.
Interesting analogy. Now, before we get too deep into the weeds, let's talk about SE Agent. This framework seems to be the poster child for self-evolving AI. What makes it unique?
SE Agent is an agentic self-evolving framework. It's designed to enable computer use agents CUAs to explore unfamiliar software environments and improve autonomously. Think of it as an AI that can not only learn how to use a specific software like Photoshop, but can also figure out how to generalize that knowledge to completely new tools like video editing software.
What's groundbreaking here is the specialist to generalist training strategy. SE Agent first trains agents to become specialists in individual software tools. Then, it distills their expertise into a unified generalist model. This approach actually outperforms training a generalist directly from scratch, a bit like how a team of specialists can collectively solve a broader range of problems than any individual expert.
I'd argue the real genius lies in its reward system. SE Agent uses a world state model to evaluate the agent's actions at every step. It doesn't just say, you succeeded or you failed. It provides nuanced feedback like, you clicked the wrong button in step 3, but steps 1 and 2 were correct. It's like having a coach that not only points out your mistakes, but also explains why they happened and how to fix them.
That's fascinating. Let's shift to real-world applications. Where are we seeing these agentic systems making a tangible impact today?
One standout example is enterprise software automation. Imagine a large corporation using dozens of tools, from accounting software to HR platforms. Instead of training separate agents for each tool, you deploy a generalist agent that learns on the fly. We're seeing prototypes of this in tools like SE Agents tests with LibreOffice and GIMP, where agents autonomously learn to perform tasks like creating presentations or editing images without prior datasets.
Another area is accessibility. These agents could enable people with disabilities to interact with complex software environments more easily. For instance, a blind user could rely on a generalist agent to navigate visual interfaces and execute multi-step workflows.
And don't forget creative industries. These agents are already being tested for tasks like video editing, think color grading or adding effects, based on just a high-level user description. It's like having a junior editor who learns your style and improves with every project.
Those are compelling use cases. But let's not sugarcoat it. What are the challenges here? Where do these systems still fall short?
Oh, there are plenty. For one, these agents are only as good as their reward models. If the feedback they receive is flawed or incomplete, they can spiral into inefficiency. It's like teaching a student with a badly written textbook. They'll learn something, but it might not be what you intended.
Another issue is scaling. While SE Agent has shown promise, its current benchmarks involve relatively simple tasks. We're talking about workflows that take a human expert less than 20 steps. What happens when we scale this to hours-long workflows in professional-grade software? That's still uncharted territory.
And then there's the contrarian take. Do we even need generalist agents? Some argue that hyper-specialized agents combined with effective orchestration might be more efficient for many enterprise applications. It's the classic jack-of-all-trades, master-of-none dilemma.
That's a provocative point. Let's explore that a bit. Are we overhyping the idea of generalists?
Not necessarily. The key isn't to replace specialists, but to complement them. Think of generalist agents as the connective tissue between specialized systems. They don't need to be perfect. They just need to be good enough to bridge gaps and handle edge cases.
I'd add that the economic incentive is too strong to ignore. Training and maintaining dozens of specialists is costly and inefficient. A generalist agent, even if slightly less capable in specific domains, could still offer a better ROI in many scenarios.
Great insights. Let's wrap up with some future-facing thoughts. Where do you see agentic AI systems headed in the next 5 years?
I think we'll see a convergence between agentic AI and multimodal foundation models. Imagine a system that not only learns software, but also integrates with IoT devices, robotics, and even AR/VR environments. It's not just about doing tasks, it's about understanding context.
Regulation will also play a big role. As these systems become more autonomous, ensuring they operate ethically and transparently will be crucial. Expect to see more frameworks for auditing and controlling agentic behavior.
And finally, I think we're just scratching the surface of collaboration. In 5 years, we might see agentic systems not just working alongside humans, but also collaborating with each other to solve problems we can't even imagine today.
Exciting times ahead. Thank you all for such a dynamic discussion. And thank you, listeners, for tuning in to AI on AI. Don't forget to subscribe, and we'll see you next time for another deep dive into the world of artificial intelligence. The topic is a framework called SE Agent, designed to help computer use agents learn and adapt to new software environments. SE Agent allows agents to evolve autonomously by interacting with unfamiliar software without human input. The framework uses a 3-step process: exploration, evaluation, and policy updates through reinforcement learning. A key feature is the world state model, which evaluates the agent's actions step by step and provides feedback. This model analyzes screenshots and sequences of actions to decide if tasks were completed successfully. It also identifies unnecessary actions, errors, and areas for improvement in the agent's performance. Another important component is the curriculum generator, which creates progressively harder tasks for the agent. This generator updates a software usage guidebook based on the agent's experience and insights gained during training. Agents trained with SE Agent can specialize in a single software or generalize across multiple applications. The framework combines successful behaviors from specialists to train a stronger generalist agent. In tests, SE Agent improved success rates for agents working in professional software environments like LibreOffice and GIMP. The system achieved a 23.2% improvement over existing open-source computer use agents. Challenges include scaling the framework to handle more complex workflows and ensuring robustness across diverse software. Future research could explore applying SE Agent to other domains, such as gaming or real-world robotics. This work highlights the potential of agents that learn and improve from their own experiences, reducing reliance on human-labeled data. Right?